Where did this idea come from to get this machine made out of metal and then utilizing generative design to make it work better?
I think it comes from an innate nature to make things hard for myself.
Why do you need so many amps?
I don't, but I can.
I worry about you sometimes.
Oh my gosh.
Oh God.
I have a customer that believes in the flat earth and all that, and that the moon landing was faked. I'm like, I think I'm working with Dale Gribble. I think they've got a deep, very thick Southern accent too. Rob Lutter says a flat earther in Florida. Imagine that.
You scan the model fixtured into the build plate. So you have all of the reference point of the fixture that you can reference off of, and then you can print onto it.
Jacob doesn't know anything about that, about launching a printer a couple of days before another machine comes out and becomes a huge problem for him.
Oh, my SEO will never forgive me.
No, it's okay.
It was bad. We wasted so much money.
We're hanging out with Rick and Andy from Generative Machine. We're going to be talking all about 5-axis 3D printing. Gents, introduce yourselves. We'll start with Andy since he's next to me, and then we'll go down to Rick.
Yeah, I'm Andy, working with Rick on this printer, mechanical and software engineer. So I've been making it move and do things. Used to work at E3, done some stuff with QA.
Nice. I didn't do my normal intro, which is I need the Backstreet Boys from you, which is the who you are, the where you from, the what you did, and as long as you love us, since it's now Jacob and I together, I guess. Rick, intro us, please.
Yeah, I'm Rick, and I work with Andy on launching this machine. I'm just doing the reverse of Andy's intro. Before this, I was a researcher. I was working on this kind of stuff, and then I thought that the cool thing to do would be to just actually do it and go out and start making these printers and try and bring them to the market. So I've been putting together a team with kind of like Andy and some others. We've just been making it happen, taking it out to the Denver Rep show where we met you guys.
Yeah, and it was legitimately just one of the coolest things that I've ever seen as far as 3D printers go, right? Because realistically,
I mean, I literally had you sending me messages when you got to the show, being like, Jacob, look at this.
It is.
Look at this.
You did have me doing that because I was very impressed, which at least when it comes to different tech in this industry, it is harder and harder to do these days. And whether that's because I've become Shania Twain or something, neither here nor there, that potentially the Brits won't even get that reference, it is still something that's like, this is so far outside of the box. Because not only did you decide to do a 5-axis printer, which is complicated in and of itself, you also said, screw it, we're going to make a 5-axis machine and then we're going to print it out of metal because why not, right? Where did this idea come from to get this machine made out of metal and then utilizing generative design to make it work better?
I think it comes from an innate nature to make things hard for myself. It would have been really...
Think about that. We don't know anything about that.
Yeah, because these are all things that you kind of see, but you don't really... It's hard for people to really get to grips with what's going on. You don't see it every day. You see it in niches like aerospace. And we really want to bring it more to the forefront and start using the tech so that others can start, seeing what we're doing, using it, learning how to use it themselves. That's the kind of stuff that we're interested in.
And so do you have a background in this, or is this just like, oh, hey, I think this is going to be fun, let's just do that?
Yeah, well, I started, I guess it was about 2013, so I've been in it for a long kind of time.
Okay, yeah, you're definitely not a spring chicken if it was 2013.
Yeah, I think it was Rep Huxley, the first one we started playing.
Wow, yeah.
We were putting, at the time, we were already putting webcams on it and sharing the files on Thingiverse to monitor your printer through your webcam setup.
Okay.
So you definitely have a bit of heritage then.
Yeah. It's one of those things that just never goes away. 3D printing. But as it's gone on, it's just naturally been something that I've been engaged with. I guess Andy too. Andy's experience.
Yeah, Andy. When did you start in the industry?
I think 2015. So when I started stop and date myself, I started uni. I went to the 3D 3D printing lab, and at the time, they didn't really have very good printers, and they didn't really know how to use them. So I bought my own, and just went from there.
So a lot of this is just coming from the perspective of F it, we'll do it ourselves, right? Where you haven't found specifically what you're looking for, and instead you said, you know what, screw it, we can just design something. Is that fair?
Yeah, I think I was interested in the process rather than the necessarily getting functional parts. More interested in the how to make something that can make functional parts.
Okay.
But you've definitely chosen one of the hardest ways to go about doing that.
There's plenty of ways to design 3D printers, and they're all valid for their own particular reasons, one way or another. This one, however, is You've taken what a lot of people have said. This is the most challenging format for 3D printing, which is metal, right? A lot of people say metal is the most challenging format for 3D printing. And you've said, forget it. We're just going to go ahead and then make it 5x.
Yeah. Yeah, there's a lot of machining, actually. It's not just printing. To get things then precise, we machine the parts.
Are you post-machining the
reference
metal
edging.
parts or no?
Yeah.
Wow. So you're going even further into the realm of over complex.
Yeah, and the hard bit is getting them actually made to the tolerances that we specify. Because we want to make a precise machine, especially for 5-axis, we need to be running very straight. So to do that, we need high tolerances. And then I guess for the manufacturers to do that, they've got to work out the jigs on how to machine these parts, which are, because metal printing, it can warp like 0.4 mil or 0.2, 0.4. Yeah. So you've got to consider that when you're designing the parts. You've got to think, right, I've got to machine these after if I want it to actually be kind of straight. And that's where a lot of the work goes into. It's figuring out how is this design going to work to be accurate, and then how do we machine it?
Yeah.
So you're going from printed powder to then checking probably not checking, but going straight to post-machining. Sub-manufacturers that are surfacing your parts must hate you with the shapes that you're giving them. It's like, here is a random shape. Go figure a way how to hold this square.
Yeah.
Where's the reference edge?
Yeah, that's usually it. Where the hell do we clamp this? But they find ways.
I say
It's
you could also
amazing.
design in the clamps if you really wanted, or design printable jigs to do the holding. We work with a couple of companies that do this. They will 3D print out of metal, deliberately make it large. They know it's going to be out of spec, and so they don't even measure it anymore. They know, unless the machine crashes, this is going to be bigger than we need it, and then they post-machine it down to a more reasonable tolerance. So we're seeing this a lot in the car community. Hilariously, turbochargers. You know, the turbine wheels that will spin upwards of 90,000 RPM, right? Just absolutely insane things. Yeah, they're not machining them stock anymore. Companies are 3D printing them out of titanium, stainless, whatever materials that they might want, and then they're post-machining because that process is faster than just starting with one big block and having to slowly 5-axis machine it all out. And that's how we're getting like multi-geometry turbochargers, multi-vane turbochargers. That technology hasn't existed until this now is currently possible. And it is a fun way to take the tech to a different level, because we're dealing with something where, like you said, it's going to have 0.4 millimeters or so worth of deviation. If you're trying to hit 100%, make the part a millimeter bigger than it needs to be, or 2 millimeters bigger than it needs to be. And you don't have to do the measuring. You just go straight into machining because you know it needs to be machined, and you can deal with the measurement after the machining and dial anything in that's necessary. At least is that currently how you're doing it, or is this just whoever's doing the post machining, that's their problem?
Yeah, no, we definitely got to think about it. So but oversizing things is one way to go about it.
Okay.
For sure, that's pretty much the only way to go about it. You got to oversize and machine away. Some early work we did, I think Autodesk printed the parts for us, and we learned quite early on that you've really got to think about this warping in the part, because then when you machine it, it might not machine the whole surface, and you'll see that there are areas that it's missed because you haven't put in an extra mill. And you learn quickly the best way to do it is put in extra material and then machine away, usually.
Well, and you're also playing with one of the harder materials to 3D print in metal. So people that are mostly used to doing machining in general know that 6061 aluminum is like the bread and butter of the machining world. It's super easy to machine, other than it can fuse to the bits from, you know.
Wait, are you telling me that's not steel that was printed? That was aluminium?
One of the parts is steel, the print itself.
Jacob hasn't even let me go to the fact that aluminum is one of the harder materials to print because it is so good at wicking away the heat when you hit it with a laser. And it's why people like to machine it, because it doesn't need as much cooling as something like steel does. And because it's a softer material, it's easier to machine. But for 3D printing, it's quite the opposite. It's one of the harder materials to 3D print because
the only thing I know about aluminium versus steel for printing is every time I said, can we get this in aluminium, there was a service rep telling me for 45 minutes why I do not want this in aluminium and it should be steel or any other material but aluminium. And then I brought up copper and they just looked at me funny and didn't continue the conversation.
No.
Yeah, copper's bad. Not bad.
Very bad. That's why niobium exists. It's a copper alloy that, right? I believe it's a copper steel alloy, if memory serves me correct, of how niobium is made. Niobium, you can 3D print in niobium. It's pretty much only used in rockets. We're going to put very big air quotes around the term rockets because these are rockets that tend to go, let's just say,
spicy candles.
Well, some of them look like spicy candles from where I'm located. Some of them look like spicy candles from halfway around the world from where I'm located. Those are very different levels of spicy candles. Some are sending satellites into space. Some of them are delivering packages to other countries. And unfortunately, all modern rocketry utilizes 3D printing in their engines because it is just more efficient and it's considerably more affordable. But you guys went down this path of saying, well, we don't really care about affordability. We want to use generative design to build a machine from scratch that is able to be as weird looking as humanly possible, but still meet all the standards that we need for keeping it sturdy, correct?
Correct, yeah.
I mean, what ended up pushing you towards that decision of going metal instead of just, printing it like every other chump out here?
Getting stiffness into the really, really solid. These frames don't really move too much. And aluminium, it's funny because the supplier we work with, they can get the best accuracy with aluminium, which is why they keep saying, aluminium's the best one to go for. So we tend to keep going with aluminium, despite it being a bit explosive and stuff, but they seem happy.
It is a spicier material. And this is traditionally DMLS or LPBF, right? So that's direct metal laser sintering or laser powder bed fusion, right? You guys are pretty much playing in the powdered metal world, correct?
Yeah.
Okay. And
that's right.
Because the people that are doing the printing for you say aluminium is the easiest, you're like, aluminium it is. Is that kind of the way that worked out?
A little bit, especially for now, because we're still prototyping a lot of these shapes. Our design process is figuring out how to put all of the parts we need into this generatively designed package. And then we, print it. First, we print it in a FDM, just like with PLA, and then figure out to see if it fits and works together before we go and spend a small fortune making them in metal.
Because PLA is not going to perform anywhere near like the metal does, correct?
Yeah, and it's kind of, you can get there, but if you do like 5 wall thick, 5 walls, 45% infill, and if you use the really good PLA, NatureWorks. It was Andy that recommended it.
The proper, we know what's in it. It's NatureWorks. It's not some random company's regrind thrown into the black filament to make it print better.
Yeah.
Okay. Yeah.
You can get good enough stiffness to make it a part or a machine that prints fairly well. The ones on my desk, they're all printed. They're for testing, prototype.
See, I struggle with building printers on stream. This is like a known problem for me, that I struggle with building printers on stream because I break things. I'm very good at breaking things, and I'm even better at breaking things when I'm nervous and on camera and have like 30 people telling me that I'm doing it wrong. If I was printing the parts out of PLA or PETG for that matter, that would be very useful. Because wait a minute, I don't need metal. Metal's cool, but like you said, metal's expensive. What if we did it out of like a continuous carbon fiber or something where it's like a Merc forge? Klipper has become like the de facto standard for companies to use. Why did you guys go down the route of Duet and rep firmware?
It's more configurable. Klipper doesn't really support more than 3 axis simultaneously at the moment. There are some where they're doing 5 or 6 axis printing, but
I feel like Danger Klipper kind it lets you just do whatever the hell you want. But the name alone tells me that I should not touch it.
I still don't, I might be wrong, but I don't think Generative has implemented 5-axis or more than 3-axis simultaneously.
I am a Voron moron and a general Klipper idiot. So if you believe I'm wrong when it comes to Klipper, I'm probably wrong. It's much easier to just generally assume that I have no idea what I'm talking about when it comes to Klipper, because I don't. But I will say, from a perspective of someone who's built both a Klipper machine and a RepRap firmware machine, I'm sorry, but the RepRap firmware online configurator thing, like their web-based configurator, is so much easier. Now, from an editing perspective, Klipper is easier for me to mess with, but the road to get to a point where I could edit Klipper was very, very difficult.
Yeah, I don't like that you have to restart the machine every time you edit something in Klipper as well. That's just frustrating. But
I mean, that's not that big of a deal.
it's if you have to like rehome the axis every time if you're doing something that needs something to be honed, try and make a macro that does something. It just becomes a development pain for me, at least.
Yeah, like think of it, like every time you make a small change, we start. Every time. It's not big changes, like literal little small ones, we start.
Yeah. And I have to see that it kicks on every time I restart the printer, so I have like a turbine going off, just blowing my ears out.
Well, that's your fault for having a turbine that'll blow your ears out as on the machine itself, right? I guess I've never, it's been so long. My Duet board's a Duet 2 Wi-Fi, because that was the last time I built a machine, was when the Duet 2 Wi-Fi was the brand new board. And back when you could not get touchscreens for your Duet that wasn't the panel do, or whatever the hell it's called.
No, yeah, panel do.
Okay.
Yep.
Yeah. So I have the big one. I think it's the 7 or the 9. And it's offensively large.
I need to send you one of ours. It's in an integrated 7, so it has none of the extra daughterboarding features. It's basically just the screen, and it's still that large. The size matters.
The machine that it is currently on is a machine that hasn't been turned on and is currently in cold storage, but has not been turned on in 3 or 4 years, outside of proving that it still turns on and doesn't blow.
Oh no, we need to get you to make a new machine.
I need to first not blow octopus boards in my Trident before we start playing around with Grant doing more.
Look, if you can kill a Duet board, I would be surprised.
I blew the 5-volt rail.
What, on the panel, on the Duet 2? Wow.
Because if you draw more than an amp out of it, you can blow it, and I was drawing like 6.
Oh, that's fine. You just replace the replaceable fuse in case that happens.
No. I let out the smoke. But
Of the fuse, right?
No. Of the regulator, of the actual regulator, I let the smoke out. But Duet was smart enough. They knew that this is an issue. They knew that the regulator itself is not the most powerful. So you just move a jumper and you can inject your own 5-volt, which is exactly what I did. And I definitely didn't do it by taking a buck converter from the 24-volt in that we were doing and then match it at 5.0000 volts off of that crappy buck converter to make it work. But I can now draw like 12 amps on the 5-volt rail.
Why do you need so many amps?
I don't, but I can.
I worry about you sometimes.
Look, I never said I knew how to do it right. I said I know how to do it. Never once claim I know how to do it right. That's the trick. See, people just assume that when someone says they know how to do something, that they also know how to do it right. I don't.
You know what RepRap does have? Really good documentation. Like excessively good documentation.
Yeah, in the early days, the only place to find info was the RepRap forums. I still remember, I think DC42. You just see all of his comments, and that would be how you fixed your printer.
You're right.
If that's the right username.
Yeah.
It is.
Yeah.
It very much is.
Yeah. It's like,
And he's still at it.
If you were like going through the RepRap forums to find something and you saw DC42, you're like, yeah, this whatever they're saying is the right answer. I don't
that's how I do it.
anything else. Oh my God.
I still stand by. We need to make you make a generative machine now. We need to get you to make one.
Okay, again, we need to get the Trident, the easiest of the Klipper machines, running fast, and me not killing octopus boards. Thanks, Steve.
I don't know, man. It's Klipper hard.
Okay.
Klipper's so much harder.
Do you know how much street cred I'm gonna lose on the Voron people if I just abandon the Trident and just move right into doing a Duet Duet-based 5-axis machine. Like, they're gonna say you couldn't even get the Voron running. What tells us you could get this running? Like, this is what my
It's fine.
psyche.
You get to look at them, go, where is the documentation for how to get it up and running? And then you show them duets and go, ooh, maybe they can learn a thing. I'm sounding very biased against Klipper right now. It's because it's true.
Yeah, it sounds like paid promotion.
Yeah, is Duet sponsoring this episode?
Yeah.
We should. We're missing out here. The last time I compiled Marlin was when the ramps board was the board everybody was building machines with.
Yeah.
And to this day, I still have a functioning ramps board that I couldn't kill. That still works perfectly fine with the Allegro 4988 driver chips that make your printer sound like a screaming dog from 3 rooms over.
I think that just might be because you're using it.
It could be, but it does work. It does work. And it gets the metal oxide varistors on it are so large that you physically, even if you just dead short it doesn't care. It's like, you don't, your pain doesn't hurt me. I'm fine with this. So I think the ramps board was just a masochist disguised as a motherboard. That's at least my general theory regarding the ramps board. But, really, I am very curious to understand why generative design, why title of AI generated 3D printer, which is not technically wrong, but it's
That was
also
never
not
me.
technically right.
Yeah, no, I have never said it's an AI generated printer.
Yeah, it's better for
It's a weird one. Yeah, well, but it's
AI is
It's
just
all
spicy if statements. That's all it is. Spicy if statements.
yeah. A lot of the articles you read, some of them reference generative design as AI. Others, well, don't. I probably would be in the less so AI, more kind of computational design.
Yeah, I'm very much in the it's not AI, but the title of generative designed 3D printer out of metal doesn't hit the same way as AI generated 3D printer out of metal.
Yeah, it's a little different. I think it'll get there eventually, and that was the idea. It was trying to get there because when you start kind of designing things parametrically, where you design positions for motors, rails, pulleys, and you can set that up parametrically, so you can edit the dimensions, and it doesn't have to be you. It could be an AI that can edit these dimensions, and then you just send it off to the generator or whichever software you're using to generate the shape, and then you do have a kind of AI generated shape. You just have to know what you're putting into it and to kind of like the loads and stuff. But it's definitely possible.
I mean, if you build a machine that can recognize when you've walked away from your mouse for more than a couple of seconds and it clicks the button, and that is what starts the generative design process, that's machine vision, that's artificial intelligence. I think that's AI generated to click the button.
Yeah, that's exactly what we're doing now. We're going to spin out as a AI company that specializes in this tech. We're always looking for opportunities, I think.
How to get instant funding. Just be like, 3D printing? AI? Well,
B2B
seed
SaaS.
funding done. B2B SaaS. Let's
B2B
go.
SaaS. Oh God. I think that's a bannable word on this channel.
Okay, at the moment you're outnumbered. You're the one American and the 3 British people here. So earlier you said there was complications with everything you were doing. And one of the things that I actually just cannot get my head around is how on earth are you slicing stuff? Because there are no slicers for this level of...
There are some slices here.
Well, which ones? I have no idea about 4-axis, let alone 5-axis. So
Yeah, so we've been working with a company called AI Build, and they've been working with them to integrate our printer into their slicer. And there's been some notable development as well in 5-axis slicing outside of that. And Josh Bird has done some good work recently.
The only thing I know of 5-axis slicers is that they tend to be for very expensive big robotic arms and orders.
Well, those
Is there any like...
axis though, aren't they?
I wouldn't know. Many...
5 and 6 are much the same. Yeah,
I guess
Yeah.
once you have 5, adding a 6 isn't that big of a deal.
I think it's actually the opposite. It's easier to do 6, is what I've been told, and then taking one away actually makes it harder.
Huh.
Now,
I guess it does reduce the amount of
wanna know-
flexibility it has.
Now
Yeah.
I want to know why.
But then also like the 6th for additive like us, I think would be rotating the nozzle
Yeah,
around
turning the
this
nozzle.
extrusion axis, which if you have a symmetric tool doesn't really do a whole lot.
Yeah.
If you have a asymmetric tools, like your clearance angle isn't the same, which a lot of robotic arms aren't necessarily symmetric around that, then having that 6th one does do a bit.
Well, and a lot of them are also dealing with asymmetric nozzles nozzle orifices, right? So
Yeah,
when we look
exactly.
at like, for me, the 6-axis world for 3D printing is almost explicitly in concrete, right? So building homes and things like that, which I think is super cool. One of my favorite ways to use like big, stupid 3D printers is to build homes with them. And they often have a rectangular nozzle opening so that they can get really like perfectly flat top, smooth layers of concrete. And that's where having that 6th axis to be able to rotate it like around a corner matters. But if you're just using a concentric nozzle on the rotation axis, it doesn't matter all that much. But I guess you probably run into more issues with your wires first, right? You probably run into like heating issues.
Oh, we run slip rings on the new design, so we'll rotate it and just slip with the heating.
That makes
If that's what you meant by
A
wiring.
simple, elegant solution.
Well,
Yeah, but quite a headache to design a simple, elegant solution.
if it is easier to do 6-axis, why not integrate a 6th axis that just doesn't do anything?
I think typically 6-axis is robot arms where you have your 6-axis that way.
Where the platform is stationary, and in your
yeah.
case, you're doing more of a trunnion-based platform where the platform itself is moving rather than, something else, right? So instead of the arm moving, it's the trunnion thing.
Yeah, we have both the bed and like a cantilevered axis. So we've got two things moving, and rather than a robot arm, we've just got one, but just the end effect is moving.
So was there any like big complications then going from a slicer traditionally for bigger machines and scaling it down to something that, from my experience, is smaller than the print head of those bigger machines?
Yes. Yeah. Because everything is calibrated for these huge robot arms. So we have two extrusions.
Not as calibrated. They can accept smaller issues in an extrusion.
Yeah.
That become a lot more prevalent in.
It's like the tolerance level of a big arm printer is measured in centimeters sometimes.
Yeah, exactly. We're looking at under millimeters.
Well, there are companies that are like doing like Relativity Space. They're using 6-axis robot arms to 3D print rockets, like not just the engines, the bodies.
Yeah, because they're doing the entire body as well,
They're
aren't
doing
they?
the whole body, but they're playing the different game where they are taking good educated guesses about how it's going to deform, like you guys have said, like how there is deformation issues when you play with metal, and they're printing it in a deformed state. So when it deforms again, it deforms into the shape they want it in, rather than it deforms out of the shape that they want it in. So they've done it a little bit differently. Also, kudos to them, because everything in their business, all their rockets and everything, they're all named after StarCraft stuff, which I love. It is just super, super funny. And for the StarCraft players out there, you must construct additional pylons. That's just one of the deals. And I believe they call their printers pylons. Could be wrong on that, but if they do, A+.
Yeah, I know with WAM, the wire arc manufacturing, the AI build, they have simulation now of the process. Not
that's cool.
not familiar with it, but they simulate the process of the kind of like melting and everything. Looking at that deformation.
Do you ever see that coming to the filament side then? Because some materials, obviously, everybody's experienced ABS. Do we see that being useful?
I guess we could do, but I don't know if it's that useful. I saw an episode of yours on nozzle cams. Was it a recent one?
Hopefully it was a good take, not a bad one.
You do not like nozzle cams, good sir.
I don't. I find them useless.
I think they're super cool.
There are some bits of research, like Caxton is one, where they're taking actual data from the nozzle cam and then feeding it. It's closed loop, and they're taking the data from the nozzle cam, feeding it into the print parameters, and adjusting kind of real time.
Markforged, on their X7 and above, they have a software called Blacksmith that does this, except rather than using a nozzle camera, they use multiple cameras inside of the chamber to basically run photogrammetry on the part.
But that doesn't count. This is nozzle cam.
I
Nozzle cam.
understand, but it's a closed loop system where they're able to actively adjust print parameters in the middle of a print to bring a part into tolerance.
Look at him moving the goalpost, so his argument makes sense. It's all about nozzle cams. Nozzle cams suck.
An American moving the goalpost is what we do, okay? We weren't the first to put anything into space. We weren't first to put a human in space, but we were the first to land on the moon, and damn it, that means we're the best at space, apparently. It's not the Russians. No. It's us. We know about moving goalposts. Deal with it.
That's if it wasn't fake. But that's another story, really.
The Earth is flat, and it's mixed 6 flat too. Yes, the entire globe is sat on a Sterret granite surface plate. It's perfectly flat.
No, that's what I do. That's what I do. No, granite's my side.
Oh my gosh.
Oh, God.
I have a customer that believes in the flat Earth and all that, and that the moon landing was faked. I'm like, I think I'm working with Dale Gribble. I think they've got a deep, very thick Southern accent too. Rob Lutter says a flat earther in Florida. Imagine that.
But thermal nozzle cams would be quite good, I think.
I think there's a lot of use for thermal nozzle cams.
I
That could be
pointed a
quite
thermal
interesting.
camera at a printer as it was printing, and it is so cool. It is
It's so trippy.
so cool. Because like, if you're ever wondering about cooling, and is your material cooling evenly, just a thermal camera will tell you all of these things, and it does not have to be the greatest level of quality. It just has to be okay, and it works really, really well. Like really well.
Which camera do you use?
I have just a
You did
generic.
one of the Blur
It's
iPhone ones.
A Chinesium clear
Oh.
camera. Yeah. It was like $150 US, and its base resolution is 96 by 96. But it's got some sort of super sampling that allows to get to 256 by 256. It's actually, for what I paid and what I get out of it, is very, very good. I'm incredibly happy with it. But we did just have a company reach out to use a fully integrated one that doesn't need a cell phone. Like, it's got its own screen and all that. I'm like, ooh, that could be fun. That could be very fun. Because ever since that we started looking at machines with thermal cameras, and I'm blaming Cheedy for this because it is literally why I bought a thermal camera, was because they made a 3D printer that was a fire hazard. And instead of having to like capped on tape things to areas that I think are hot with a thermocouple, can now just non-contact measure it. And it is very valuable to do testing that as a content creator, we should not have to be doing, but we do because we can't trust manufacturers. So generative.
And for things like heat breaks,
Don't do that.
heat sinks, heat breaks,
So
nozzles, if
the
you're
only problem
developing.
you'll run into with those is reflectivity.
What of the metal?
No, just spray in black. Spray in black.
That's going to change its properties for thermal.
You'll be surprised at how a very thin coating of specifically matte black, do not put a gloss on, but a matte black goes down so thin, it barely changes the thermal properties of anything it sticks to. And I know this because I used to do a lot of PC modding where you would get your air-cooled heat sinks, and you don't want them silver or copper. You want them black. And the thermal difference is almost nothing. Literally almost nothing.
I'm just saying a solid copper cooling system would be very nice. I normally have a solid copper heatsink handy, but I don't immediately see it.
Until you touch it and get some finger grease on it.
Oh yeah, no, this one's covered in fingerprints, but
The permanent mark of shame.
it is like a kilo and a half or 2 kilos worth of solid copper. They're server heat sinks. When servers get end of life, people don't pull the cool stuff out of them. I pull the cool stuff out of them when I get to see them. I'm like, hell yeah, solid copper heat sinks. Don't know what I'm going to use it for, but I want it.
They're just throwing them away.
Yeah, it's going to the trash.
I mean, that's
Cool.
literally how I ended up with my server rack. I literally did the same when we had the engineering granite surfaces. We put them in the boot, and that was a mistake and a half.
When you guys are dealing with this post machining on the machinery and getting the post machined parts, do you find that ambient temperature can play a role into surface flatness? And do you ever notice that in 3D printing?
What do you mean, for clarification?
So I figured one of the areas that you were post machining the metal 3D printed parts was like the surface plate that you then stick the bed onto, right?
Yeah. Well, no,
No.
not the bed. We just machine those straight up out of the billet. The other parts, I don't know how it affects the temperature, how it affects machining.
It's like temperature can really, it's not much, but if you are post machining 3D printed parts to bring them into spec, temperature should have a reasonable fluctuation in quality. But what type of tolerance are you holding on the printed parts that come off of the machine? Are these machines able to hold good tolerances?
Yeah. Off the machine, we get quite good tolerances straight off the print, and then we're looking at like 0.05 mil.
Oh, that's pretty good.
50 microns. Yeah, no, that's
That's pretty good.
That's post machining. So dialing everything in to be that is quite hard.
Did you have like a set machine you go to get them printed out of. So I've only ever had experience with one-click metal machines.
Oh yeah.
You have like this is the machine we like and it does what we want, or have you tried multiple?
No, we leave it with the supplier. We've tried a one-click metal. The build is a bit smaller, but the quality's
A
okay.
bit on the smaller
good.
side.
Yeah. And then for bigger, I'm not sure which bigger machine they're using for this, but no, I couldn't say which machine they're putting them on.
But I'm still impressed you're doing it out of aluminium.
Yeah.
Just straight up, like the amount of times people have told me try to avoid printed aluminium no matter what. Even though stainless is harder to post machine, the printer just works so much better. Like the spot size on the laser is like 25 micron on stainless, where I think it's like 65 micron in aluminium, just because they have to like bump that energy up and it sticks to it when it melts. Have you ever tried stainless?
Yeah, I've got some parts in stainless.
I want to see one done out of titanium, but I want to see it be generated for titanium because of how stiff titanium is and how thin this thing could end up being out of a material like titanium. Just be so cool.
Well, titanium's not that stiff though. It's kind of like a middle ground between aluminium and steel. It's just it's light. It's very light.
In my experience, titanium is considerably stiffer than steel, but I could be
Wait,
wrong.
it's soft. Titanium's soft.
Okay.
Like hard Play-Doh is when you start to like tear it, it will tear.
Screw
It
it.
won't
Pull
shatter.
that in Canal. Make Canal 718. Just make the whole machine out in Canal. The people post machining will love you. They'll love you. Don't worry. Everyone loves machining.
No,
Canal.
don't do it. You will wake up with broken end mills underneath your pillow. Don't do it.
Bill for those head mills too.
Yes, you will.
So I really wanted to like dig into the metallurgy side of it, but I think that the metallurgy has become part of the process because of the generative design. Is that correct? Like it being made out of metal is just a consequence of the generative design process, or was it always intended to be made out of metal?
We've got two. One of them is printed, so you can print it on your own home FDM machine. And then the other is specifically designed for metal, because the properties you get out of the generative design, they wouldn't really be accurate on a plastic FDM printed part. But with with metal parts, it's been designed for that specific material. We still got to test it. We make hundreds of prototypes, so we test usually in FDM each one.
Okay.
So wait,
Well,
is it
I forgot what I was saying.
now? Okay, so is it generative designed for metal or is it generative designed for plastic?
Yes, for metal. The one we have for metal is made for metal, and then the plastic one that we have is just kind of like we keep iterating physically until we get the stiffness that we need. If that makes sense.
Yeah.
I'm just trying to think of like
The stiffness
see what they
matters,
do.
but some days
Like
you
the-
don't get it. All right, don't worry about it. Wait, so that's a full FDM one then?
Yeah, this is FDM, and this was developed by we just keep tweaking it until we get what we need. Whereas with metals, then the studies are run for things like aluminium that you're printing, and you can have more confidence that it's going to actually be what you want.
And how
We
close
still-
is
you
like
still-
the study step to the actual output? Like, is there much of a deviation from the simulated stiffness to the real, or is it pretty accurate?
We haven't tested it to like academic levels of testing where we've done like a month-long study, but it's quite accurate. Yeah, they're really, really solid parts. I think if anything, they're maybe too much. They're very stiff. And I have seen some people posting on things like LinkedIn, and the point at which they break is way over what the study said it would break at.
Interesting.
And they're going to huge numbers. So
One of the things we're doing at Rocket Mountain Red Brick Festival was picking up the printer from the end of the X arm. But we're picking up from the end here while I was printing, and like there wasn't any noticeable deflection.
Yeah, Rick had me pick up the metal one from the x-axis, and I thought that I had damaged the print, but what we found out is I picked it up at quite physically the worst possible time. It was at like the absolute limit of what the
Yeah, we had an issue with the slice G code. Yeah.
like I could not have chosen a worse time to pick up the machine, and that's why there's a whole that part of the video we ended up cutting, because I'm like, it's not the machine's fault, but that was like my instant reaction, which I should have not done, because it's like, oh, that was such a cool thing to show, but we can't show it anymore because it was me reacting to something that had nothing to do with me picking it up, and I didn't know that at the time, and there was no way for me to work around that. It was super interesting to like pick it up from the X, which on a cantilevered machine, you never do. You never do that, because X itself is...
What do you mean just on a cantilevered machine? Any machine, try not to pick it up while it's working.
I think it's best to not do it on this machine either. It's not something that we'd want.
No,
Doing too
or just
often.
rearranging it on the desk. We'll have the show and we're like, hang on, it doesn't seem to be affecting the print.
Yeah,
So,
it's a cool thing to do at a show, I'd say, but not something you do every day.
I totally understand this. Like when we bring machines to shows, like I bring my Magneto X to shows, and what do? I run the speed test command under Klipper to get it just to move as physically fast as it can before it starts to lose steps. I don't ever print with it. I just put it on a table and tell it to just make crazy movements. Do I do that with the real machine? Absolutely not. I never do that because it's a massive waste of time. It's dumb. But big machine go fast is cool. Everyone likes that. So it's not practical to pick up the machine from the X. But then I would argue we got to integrate some sort of generative designed carry handle for it that's on the Z so you can easily pick it up, and it makes it really, really easy to move around now.
yeah, at the moment it's sort of like a climbing hold. You find your hole in handhold. But yeah, I think having a dedicated
like,
thing definitely.
Into the spider web
Yeah,
of
like-
aluminium to grab it, to pick it up and move it. On one of my Prusa Minis, actually on the 2 Prusa Minis that I have built, they both have handles on them because they're really awkward to carry otherwise and require 2 hands.
No,
Like
you're
the
supposed to
hand-
baby them. You're supposed to pick them up like that. Just be like, oh, it's my little mini Prusa. There we go.
I got one for free, but anyway, never mind. Yeah, so I saw one on Facebook Marketplace. Just said, here, have a Prusa Mini. I don't want it anymore.
They're good little workhorses. They're really quite nice.
They're all right until they go wrong.
Yeah,
And then they're a
they-
bit annoying.
Yeah, their Bowden tube system is just why Prusa went with brass screw fittings for a Bowden tube is fundamentally beyond me. If you replace them with push to connect fittings, it solves like at least half of the issues that I have with the Mini. And then you get rid of the Prusa hot end and put on a Revo, and it solves all the other problems that I had with the Prusa Mini. And it becomes a much more venerable machine where I can take our Prusa Mini, huck it into the back of my car, bring it to a show, slap it on a table, plug it in, click print. I don't even have to watch the first layer. I know it's going to go down perfectly. But now I take the Core 1 because I have a Core 1, and Core 1 is the new machine. So, take the new machine where you can.
The new hotness.
Yeah. So what do you, for the design side of things, what program are you guys using to do the generative surfaces for this printer?
Fusion is what you use. Autodesk Fusion.
It is.
Oh, you're
Lots
on the Autodesk simulation side.
The simulation plugin, yeah, add-on. It's got the simulation and the generative stuff. We've been using it for years. It's quite good.
How have you been getting on with that? Because I never seem to be able to get it to work. Obviously, you have proof you've got it working, but like,
Yeah, it's
how has
okay.
that learning experience been for you?
It's really straightforward. Fusion have done, I'd say, a great job of making it quite easy to start with it and start making parts. As long as you know your load conditions, that's it. It's figuring out where the loads are on your parts, where you're going to apply a load, and then you just kind of keep going, iterating, changing things very often until you get the parts that actually work. Sometimes you get something and it looks incredibly thin. It looks like a twig, and you're like, no, that's not going to work.
Well, it's like in theory, I know it will work, but in practice, no, I need it. Part of generative design, like, so we done some generative design work inside of Fusion. It works well for us. And when I say us, I really mean the engineers, because most of Fusion is beyond my skill set. Generative design inside of Fusion, that's in the next county over. Like I don't even know how to get to it. We did something similar, and we were doing it for powdered nylon printing, and it presented us with a solution with like 0.5 millimeter thick like spider webs, if you will. I'm like, while that is technically printable and will probably work, we're gonna up those to like 6 millimeters because they're going to look better. Part of this generative design, at least for us when we're delivering parts for clients, is it has to look the part as well as do the thing. And sometimes the real like deep end of generative design is not, it doesn't look the part, right?
Yeah, you wouldn't put too much faith in some of the parts. I personally wouldn't. Not, well, these I would, but
I mean, I would put faith in the parts I got out. So I had a really nice bracket. I just wanted a motor here and a wall mount there. So it should have given me a really nice L bracket shape with the spars going across.
Yes.
And no matter what I did, it was 100% 100% solid, just a rectangle with one hole in it, like, there you go. That's not going to bend.
I mean, when you
Wrong.
what I mean is when you get your load conditions wrong and you see these really thin sections, that's because globally it's not an optimal kind of configuration. And those are the parts I wouldn't put much faith in. If you've got your study set up correctly, then yes, I would say the parts are really good. But it's when it's not set up correctly that you run into problems.
It is all
Have you
about
found
finish
any
setup.
issues with trying to do generative design for printed parts? Not like the metal printing, but the filament printed side, because obviously there's not really that much data available for what settings you should put in for the generated material.
Yeah.
Like, have you
Yeah, well,
encountered that?
the results that you get are not applicable really to FDM printed parts because the layers. I can't remember the word, but there's a word for when it's not.
Anisotropic.
That's the one, anisotropic. That you don't get the results are not managed. But that's why we keep iterating with that. To get around that, you've got to keep iterating the physical part and printing them and then testing it and then editing the study to put more material in one area or another and then printing it again and testing it. It's like going backwards, but it still just does the same thing. You still get these kind of optimal structures. You just go a really long way around doing it. Like these
Okay. Yeah.
these kind of parts. But all of our parts
Oh, they look so good.
They
usually
are.
printed.
So you guys are looking to do something, have a professional do the casting then?
Yeah, I went to a place in Salisbury that does professional castings. They make well, I don't know if I can say what they make.
Dicks there.
They have a lovely cathedral if you're interested in visiting.
I don't know. How far is it from Manchester?
Quite this far as
How far is it from
Popular with
Lincoln?
the Russian-
Am I going?
Quite a distance.
Am I going the wrong way?
I think you're going.
No, you're going in a direction. Can't say it's the direction, no.
Well, see, if you keep going in that direction long enough, it becomes the direction.
But we do have the nicest cathedral. Fight me.
No, the cathedrals in Prague are pretty nice.
Nah, Lincoln Cathedral. Lincoln Cathedral is amazing.
Why 5-axis? Like, why 5-axis because you could have just done 3. You could have just done a generative design machine that's 3-axis. Why'd you say we're going to turn it up and go to 5-axis? Like, why?
well, it enables a lot, really. For me, it was printing onto part. A lot of my research before was on remanufacturing, where if you have a damaged part, you could take that damaged part, put it back into a machine and then repair the damaged section without having to make a whole new part. And I was doing a lot of that research at the time, and then 5-axis naturally is the way you do it, because you can put a part into a build plate and then print back onto the part. It makes more sense in metal if you're printing metal parts. But that was really how I got into it. It was for part repair. Looking at it as a tool for research into part repair. If you can do it on your desktop, then it's really easy. You don't have to invest in a £500,000 machine to try these things, and you can do it.
So the idea was to take something that was broken, attach it to the build plate, then print on it? Is that...
Yeah, or upgrade, not just broken. Because what you could do if you've got something already and then you want to add an attachment for something else, you could just print on the bit that attaches to something else, and you don't need to make a whole new part. But you can like functionally upgrade parts, like in theory, by putting them into this machine and then printing what you need, or removing. You can also remove material. But this is way back, old research that I was doing on remanufacturing.
I never thought of that. That would be a really cool thing to show off at shows, is to like have a off-the-shelf plastic part that you're then utilizing the 5-axis for. Because to me, I never thought of that perspective of 5-axis 3D printing, is that you're adding on to something that already exists. To me, it's just, we're doing it to like avoid support material. We're doing it to enable crazier overhangs. We're utilizing 5-axis strictly for how it benefits 3D printing, and not by taking something that already exists in a COTS commercial off-the-shelf solution and being able to modify. I've never thought of it that way. That does open up quite a bit.
That was the idea, yeah. Particularly in metals, things like WAM, because you can get functional parts. On an FDM machine, it's less functionally useful. It's still useful, but less so. And so this here's the grey part on this was printed onto the white part. It's just a model. So we were looking at how to repair broken
So you
models.
took that white part, put it on the bed, and then it set as a separate operation, then ended up printing that.
The grey, onto the top. But the code that I'd written looked at where the area was that was missing, and then it takes another reference model to fill in that area. So you take what it should be and overlay it on what it isn't, or the damaged part.
God, that sounds so complicated.
How did you get it to be at the perfect spot on the build plate like that?
You you scan the model fixtured into the build plate, so you have all of the reference point of the fixture that you can reference off of, and then you can print onto it.
And that's why you were
That's
running
really
without the
smart.
sub. Okay, this makes a okay. This is now coming full circle. I'm like, why does he care to 3D scan something in situ? Like, what's the point? Take it off the plate. I don't care if it's in situ. No. You won't
No,
scan it
in situ's needed.
Oh my.
Yes, that's it. That's how you do it. You got to have it in situ, fixtured already, because then the reference points are on the fixturing on the right.
And then it doesn't change.
Yeah,
I never considered that.
If you
That's insane.
Because God, like most 3D scanners are going to require tracking dots of some point, up to some extent, to get something like that at a reasonable like detail level.
yeah.
But yeah, that's funny because not many people run those scanners anymore because they were atrocious. And atrocious is being very nice to them for how bad.
But no, so just going back, like, so you scan them in situ with photogrammetry, and then what is the step from there? So you've got your scanned object.
Well, then it was a Jupyter notebook with Open3D going through step by step alignment. So you have the registration steps where you use an ICP algorithm to align both parts. Or before that, you can do a ransack alignment to get a rough kind of position. Fine tune the alignment with ICP. And then you separate one of the geometries from the other to get the volume that's missing. And then you can export that as a body that's already in kind of position because you've scanned the build plate and the part.
Yeah.
And then you get the geometry that you want to print. Then you got to slice it, which is easier with a 5-axis slicer. And you can print onto parts that are curved, or any part really that you can print onto a flat plane or a curved plane. But that was the reason for getting into multi-axis. And then you have the other stuff like those support stronger layers too, because you can. Well, we were testing it to show some of the parts we were making.
It's like
So you assume like you don't have to worry about the anisotropy of it because it's tilting to be whatever orientation you need.
Yeah, it might be slightly better. You need to actually test it to quantify, is it better or it'll be a bit better, but you need to get the numbers to prove it. But yeah, you can get stronger parts, pretty sure. And then there's less. I wouldn't say that's the biggest advantage of it, because supports you can get rid of quite quickly. It's the cool stuff that I think is the big advantage of 5-axis.
But that to me, that was never something that I've thought of. So like, this is mind blowing to me that so like, I've always looked at like 5-axis and seen what Brendan Builds is doing, right? And like, yeah, how he's just doing all this crazy stuff. I'm like, oh, that's cool. I don't necessarily have a amazing use case for it because the build volume itself is the more limiting factor for us. But being able to fixture an existing component, like I'm looking at all of my camera gear saying, this could be very valuable if I could fixture pieces of like a camera cage or the side of my Sony camera, like scan it, 3D print it, and then be able to make custom strain relief for the side of my Sony camera. That would be amazing.
Yeah, AI Build in their recent update, I think last week, have introduced a really easy way of doing this. The whole alignment thing over to the printing onto surfaces. It's one of their features for remanufacturing. I think it's very useful in large format and metal as well.
It's like for metal, I guess I am used to, so like the company that we work with to do metal 3D printing, they are ISO 13485, if I'm correct. They make spinal fusion jigs. It's the ISO for permanent internal use in the human body. I forget exactly which one it is, but it's the one for permanent use inside of the human body. Hey, it's not about the size, it's about how you use it, okay?
Someone wanted it even smaller. Well, they're like, could you do it smaller?
Why?
Why? Well, yeah, we could do like half the size, maybe even smaller.
But why?
We pack in quite a lot of build volume for the site. I think it was a showpiece, probably. Something to show.
I mean, it's already cute. It's small box size. Like, it's already cute enough.
The new one's a bit bigger. It's not released yet. The new design is
nice,
much larger.
See, I'm looking.
Can you talk about the improvements you've made?
There are many
information.
Many improvements. We're running heated bed. I don't know how much we can talk about, but we've practically designed it all from the ground up for production, so that we have a machine that's reliable, well made, and works really well.
I mean, so I know that you've got closed loop, and I actually wanted to touch on that because I feel a bit outspoken with closed loop in this industry. I've always believed it doesn't really have a place in 3D printers because it's either they're never used because your machine is already accurate and it's only there for stall detection, really, to see if you've lost tolerance, or it's for massive CNC industrial machines, never really 3D printers. Like, what was like the impetus to put closed loop on? Is it actually useful for you?
Yes, it comes back to fixturing. If you set the closed loop and then you put your part in, if you knock it out of position when you're trying to fumble around and fix a part to the build plate,
That's a
it
problem.
goes back to 0. So we can set it, fixture something, and then with the closed loop, know that
That makes so much
more or
sense.
Yeah,
Yeah. Closed
Jacob.
loop motors tend to run quieter and you can push them a bit harder as well. Because they,
How can you do?
yeah, basically the way that the current is set means you're not running at the max current all the time. You're running at the current required to maintain the position, which most of the time is a lot lower than the max current. So then when you're doing like accelerating moves where like the position error gets a bit larger, it then ramps up the current. So you can stick your maximum current higher because the average current is going to be lower. So the temperature is colder, if that makes sense. Because like, if you stuck the maximum current higher on a open loop motor, then it'd be that current all the time. So the motor's going to get hot quite quick. Whereas with closed loop, the average current doesn't like go up to what you set except when it's needed. With the rotary axes as well, like collisions between the bed and the X country are a lot more likely to happen if you have bad G-code. Whereas with a 3D printer, you can set soft limits in your axes, and for the most part, you can be sure you're not going to have a collision unless it's colliding into the part. But if you give a machine like this bad G-code, then you can get a collision relatively easily. But there's still a fair amount of safeguards to put in place.
To do it for you guys, you did it to maintain the steps. And I got to experience that. No, they had a cool demo where it was 2 axes that you could actually rotate and they would go right back to where they were. And the Duet would recognize that that something had been moved. And that's part of the software that you guys have behind this machine, right? It is the software integration is what
that's
makes it
part of,
unique.
RepRap, yeah.
Was there any like firmware complications getting 5-axis and RepRap talking nicely with each other?
At the moment, we're not doing like inverse kinematics in the firmware. So it's just doing motor position with G-code rather than world coordinates. But there is a fork of RepRap that hopefully will get merged into mainline soon, which does like the inverse kinematics for you. And then it takes a lot of the load off the slicer, which also opens up to make it easier to integrate this machine into other slicers.
5-axis, when you think of speed, is different because of how everything has to kind of work together. 3-axis fast is literally how fast can it move in the X, the Y, and the Z. But with 5, it's now how fast can X, Y, Z, A, and C all move together for that speed. So it ends up being considerably lower. So your new machine in 3-axis mode is very fast. Is that correct?
Yes,
Okay.
it's looking fast.
Are we going to see it, Smurf?
It's in March.
Oh, March next year,
Yeah.
obviously.
Yeah,
that's gonna
it's
be fun.
normally in November, like right around Form Next. But they moved it into March.
Might be at Form Next. Not sure yet.
Is the goal to release it at Form Next then?
I'm not sure. I don't think so. We don't really have a goal to release it at a particular event.
Yeah, release it when it's ready.
Yeah, when we're confident that it's ready to go out into many people's hands.
That's a good mindset to have.
See, that's
Yeah, don't want to run.
Not for everyone.
Have
well.
to,
See,
to
that's
do a
the
bunch
nice
of
thing
support
about
on it.
being a smaller company. You're allowed to just say, yeah, it'll be out whatever the hell we want it to be out. If you want it out earlier, sucks to be you.
Until someone else does it first, and then you're like, oh, I was.
Jacob doesn't know anything about that, about launching a printer a couple of
Nope,
days
definitely
before
not.
another machine comes out and becomes a huge problem for him.
Oh, my SEO will never forgive me.
No, it's okay.
It was bad. We wasted so much money.
You guys are still using actual steppers then with closed loop. Why not push over to servos other than cost?
Yeah, I guess cost and ease of control them.
Cost is really the big one?
Simple. Yeah.
Okay.
I mean, closed loop steppers integrate well into the Duet ecosystem as well. So
Is closed loop something you would pay extra for? Because I'm not certain that a lot of people really need it. I understand why it's useful for generative machine, but I'm thinking as 3D printing in general, is it something that people would pay for, right?
So I've seen Bamboo does it with their H2D hot end and their, I think it's the A series hot end does closed loop servo.
No,
Yes, they do have the extruder, but not X and Y.
yeah, it's
they do
just
it
on the
X and Y.
extruder, just on the H2D, and it's also in the AMS, apparently. I don't know why, but it's also apparently in the AMS.
So I think they're doing that just for like really ghetto filament detection.
They're saying that they're using some of the data for pressure advanced collaboration.
Honestly, with the amount of engineering they put into that H2D, it could be there to collect your IP address, and I would still say it's a valid reason to have it. I'm not certain that the uses that we can think of are anything of the uses that it's actually for. The method at which you could use closed loop or servos to detect would just be amazing.
I've read on forums that people when they're printing materials that are filled, like carbon filled, that they also see performance improvements because of something to do with the surface roughness. I don't know. They could only print these specific materials when they have the closed loop running on the
That's an
XY
odd one.
axis.
Interesting.
Because like,
But I've only read that. I've never experienced it.
This closed loop step is where you have the stepper motor has a mini MCU on it, and that does all of the control loop by itself, and the control board just gives it step and direction. That's not what we're doing because that doesn't really give you much advantage. With RepRap, the main board is controlling the control loop. So it's measuring the encoder data, it's looking at the target position and the actual position and controlling the current directly. It's not just sending step and direction to the motor and hoping that it's going to be in position. So the main board does all of the control loop, which gives you better precision and better performance.
so what size steppers are you guys using on the current machine? And if you care to tell us on the next iteration from Generative Machine.
Yeah, newer 17s at the moment.
Okay.
It's the standard. They work well for this form factor.
Okay.
Yeah, I was looking for an example of the ones with the quadrature encoders on them. I've usually got a few, but
It is definitely interesting to see adding encoding and adding all the detection and things that you need on this. To me, makes it a whole different animal. And I think that it's like you can use the quadrature encoding system to get higher accuracy at higher speeds and deal with jerk in a completely different manner, correct?
Yeah. You can. So it's not a PID loop that it's running. It's a PID VA loop. So a lot of the feedback is a VA, which is velocity and acceleration. So rather than just doing PID, means that when you are moving at a higher speed, you can run with a higher current. When you're moving with higher acceleration, you can increase the current. Using the VA parameters, I've found gives better print quality than just like standard PID loop.
Oh, I'm getting way too many ideas just talking about this. So, Ron, do you know how easy it is to implement closed loop on RepRap other than the G-code side? Like actually put it on an already existing machine?
Well, apparently it's impossible on Klipper. So no, I'm not aware of how.
You can go on Duet's website right now. They do sell, I don't know if you'd call it a daughter board. I call it a hat because I think it's cute. It's literally just a really simple PCB that you glue a magnet on the end of your stepper motor, and then you put the PCB on top, and it's a Hall effect sensor. And that's pretty much all it is. And you plug it into one of the daughter boards, and then that is how you do closed loops. It's really easy to implement.
Yeah, you can turn any motor into a closed loop motor. You can also get motors like we have with encoders already on them.
Like, so then why is quadrature the chosen method here rather than just gluing the magnet and using the little hat? Or so why do it this way rather than Hall effect?
Assembly time. The gluing the magnet is fine for if you're doing a couple of them, but it's an extra assembly step that if we can reduce that, like time and motion, is that a term? If we can reduce that, it reduces the cost of the machine.
Yeah, gluing those magnets onto my motors were more of a faff than I want to admit.
Yeah, you accidentally glue it to the jig to hold the magnet up. They sit and make things slightly sloppier. It's an experience. It's fun.
See, you say it's an experience, but I'm not certain it's an experience that I personally want to partake in.
It's okay, guys. You'll find a way how to to make it even worse for yourself. You'll somehow get enough super glue on the magnet for it to ooze down into the bearing and seize the entire motor.
I do still have a few gallons of super glue handy. That is possible. I could drop the whole motor into it.
You can get ones that you bolt onto the motor too, where you have to take the screws out of the motor itself and then replace it with a longer screw and bolt the encoder onto the back.
That makes sense.
Yeah, you just don't want to open up your motor when you're swapping out the screws.
Yeah, it can, if it picks up a little piece of swarf or something in there. Oh, yeah. No, it's,
Yeah, I don't know how true it is, but I was always told that there's an extra like magnetization step for something in stepper motor assembly. That means that if you open up the stepper motor casing, you lose some of the performance of it.
I think I've heard of that. Yeah, because so I've got my explainer motor here where I stripped it so I could explain somebody how motors work. I put this back together, put it in a machine. The machine would not pass any of the QC tests, and it was this motor.
Yeah.
It was insane how it just stopped working.
Yeah, you can't even turn by hand anymore. You feel like crunching at every step. It's not very pleasant. Sometimes you got to be really accurate.
Especially those motors where they have the wires soldered directly onto the coil.
Yeah.
And then you see people like opening up the motor to resolder a broken wire. And you're like, well, that motor's just not going to work this in now anymore.
Come on, guys. You know you want to do it.
what?
Closed loop, Duet powered, rep wrap, Trident.
Magnets.
Okay, if we're going to do this, I want to do it on a brand new machine. I want to do like a from scratch built machine.
You could build one of our 5-axis ones. The FDM. If you have a 300 mil build volume,
I have
Zed,
plenty of those.
you could just print one of our frames and do a from scratch 5-axis print, builder print.
Andy,
Yeah.
Andy and Rick, are you all volunteering to help me on this?
Yeah, absolutely.
Are you certain? You gotta be really sure you want to do this before agreeing to this.
We could wait till we've got the assembly guide written internally and then give it to you to see how badly we've written.
Oh
this.
yeah, I'm actually
Yeah.
really good with that stuff because I'll look at it and say, what the hell? So like the Voron assembly guide, I have so many bad things to say about it because it makes a lot of assumptions. It makes a lot of assumptions that you fundamentally know what you're doing. I don't. And unless you read the manual ahead of time, which by the way, it's like 90 plus pages at A4 size, right? It's deep, okay? You're going to have a hard time. There is nothing in the build guide that says to read the entire manual before even starting to print parts. Nobody told me that making a Voron with 5 colors was a bad idea until after I had decided that I wanted a Voron with 5 colors. And when I
the problem
decided
was you
that I want a
decided you
Voron
wanted a
with 5
Voron.
colors, I'm doing a Voron with 5 colors regardless of the amount of effort that it takes.
You should have done 5 of the like multicolor filaments, so it's 10 colors.
Look, my printer has now gotten to a point where it is just, how can I offend the most people possible? Like, we had people that really wanted me to peel the paper mask off, and then there were others that said they didn't. And I said, okay, whichever side donates more wins. They donated the exact same amount. So I peeled and tore it a bunch, and so there's some of it that's peeled and some of it that isn't, just to upset people. But yeah, documentation is a big deal. It's why I like Prusa kits. If you build your documentation and your assembly manual to the same standard at which Prusa does, I don't think you're going to have issues. Because like they tell you when to take breaks and how many gummy bears to eat. And like, I appreciate that. It warms my cold,
We'll
dead
just
heart.
take the simple pictures and leave the context.
Well, yeah,
I see no way this could go wrong.
GPT to transfer over the manual.
Actually, to be fair.
Okay,
so,
now I'm kind of curious to see how good it would be if you did that.
Translators
It would be the
actually
same.
hate the fact ChatGPT is great at doing language-to-language translation.
Yeah.
Okay, well, wait a
It
minute,
has
wait a minute.
honestly demolished their entire
What if-
industry.
Yeah,
what
I
if-
use
what
it
if-
in
In Python.
What if you uploaded
translation
the
language.
entirety of a Prusa assembly manual, uploaded your assembly manual and said, how can we make our assembly manual mimic the quality, experience, and everything that is of this? How useful? That seems like something that could actually be pretty useful.
I have no doubt it would work. it would make our lives so easy as
Yeah,
well.
And Rick, to go down this path
we don't want
further
to do that.
of when I hit my head, someone said I needed to wear a hard hat. And so I went and grabbed a hard hat. And so anytime I'm on my standing set in my garage and I'm working on a machine, I wear a hard hat. It's part of the deal is that I'm always wearing a hard hat. And hilariously, it's actually helped poked me a couple of times when I hit my head on like the corner of the aluminum extrusions or aluminium extrusions, and it's like really sharp. I hit the hard hat. It's no big deal. It's fine. But
Wow, imagine having PPE and it does its job. Ooh.
yeah, it's also just very hot. It's like on a scale of like 1 to 10. So I'm going to put like, Prusa being a 1 and like the D-bot that I built back in 2012 being a 10 because I had very little documentation. And was very difficult to assemble, was complicated and all that. Where do you think this assembly is going to be? Is it going to be somewhere on the upper end of that, or is it going to be on the lower end?
I think 0.5.
About a 5?
6.
5, 6?
No, 0.5.
Oh, not point.
Because we've consolidated all of the parts into one, basically, for each axis. You just put things in where they go, and that's
Yeah, you're pretty much bolting rails onto the frame and then things onto the rail carriages. Since there isn't a whole lot of assembly for it because the generative frame takes so many parts into one.
Right.
yeah. And
So,
you
as
maintain
far as
alignment.
assembly goes, it's actually not bad at all, is it?
No, it's really good.
It's one of the reasons for the generative design.
I will send you guys my engineering Bible so you can see how we've laid out the build step by step.
Yeah.
Yours will be much thinner because yours isn't thousands of parts being added together.
Yep.
I usually it's really thin.
Yeah.
Yours is going to be stupid simple.
Ours is 4 parts when you think about it. It's just consolidated down into each axis.
But don't be like years ago, a buddy bought one of those like DIY gazebos, and the instructions were unpack, put bolts through holes, gazebo. It was like 3 or 4 total steps, and I'm like, where's the rest of it? They're like, no, this is the instructions. I'm like, no, these are not the instructions. We're missing a lot of fundamental, like what goes where. Oh, we'll follow the picture. The picture's not descriptive enough, man. Like, I am happy to review that build guide and see if it's something that I want to take on. But I think I might want to do 2. One that is FDM and then do one that is metal, but do like crazy metal, like really, really like top end, right? Reach out to like, a friend that has access to like niobium and Inconel and get it made out of one of those, right? Just have like the world's most ridiculous 3D printer and then gold plate it because we can. Wait, I could gold plate it. Oh, I could gold plate it.
I've been thinking about getting one engraved. Like you getting really nice pattern.
Yeah.
And having the whole thing like engraved all the way around. That'd be incredible.
I'm from the South
would
in
look so
the
sick.
States, so like the first thing that comes to mind is like a really nicely engraved firearm.
That's exactly what I was thinking. Yeah.
Yeah, like a nice slide. Oh, that'd be so dope. But that might be complicated because of the granularity of the metal. Might be
Yeah, it
difficult
might
to
be.
engrave. What you could do, fiber laser.
We got diode lasers around.
The diode fiber laser. Like you want.
No, you need to.
It could scorch if you gave it a coating.
Yeah, you got to coat it first, and then probably hit it with the laser after.
Yeah, but
I
that's
think.
just
We'd have to
surface
try it.
coating. I'm looking at like deep engraving, and a fiber can do deep engraving.
I've been following a guide that does engravings to see if we can get one made engraved
Oh, like OG engraving
by
with-
hand. Yeah,
Oh yeah.
but that might be a bit expensive.
Well,
See
no, then
the
you- then
bedazzled
you-
version with just like little gemstones inlaid like all over.
Yeah.
Look, if Big Tree Tech can put moissanite on the side of a E3D Revo for their Diamondback edition, you guys can do this because they have a special edition that has a diamond. It's moissanite, but moissanite tests as diamond with a diamond tester.
I think we might go back to wrapping nichrome around the nozzle though.
There
Maybe
can,
it's an idea.
I have a new nozzle that has that. I can't remember
Jean-Francois.
what one, there is a new nozzle.
Is it one of the VZ what one?
Oh yeah,
Like-
and the Goliath has one as well like that.
Yeah, I've seen that. That's pretty cool.
What direction do you guys really see this generative design going for these machines? Do you think that you've kind of nailed that happy medium between it works great and it is absolutely beautiful, or are you always trying to push that line further?
Well, we're going for precision. We're trying to get the machine to a point where we know that it prints what we want it to print and precisely. I think that's our focus at the moment. Quality, making sure the quality is really good.
And as you're coming out with the next machine, as you've hinted, printed. Is that like the way you're going? Is make it bigger, make it slightly bigger, make it slightly better, and like iterate through that? Or is there like an end vision that you have in a couple of years? Let's say 2 years down the line. Where do you see yourself?
I think the idea of being able to print onto things with high accuracy, if we can do that, I think that's a good start. And it's making sure it's less of a printer, it's more of a platform that's multi-axis.
I'm over here thinking like, okay, it's like I've got a bad back. If I was able to scan the bed of my foot under pressure and under no pressure, and then cut a shoe apart so I could scan the I don't know, the last inside of the shoe,
The
sole inside of the shoe, and then 3D print something that is perfect for my, that would be so cool. I've done 3D printed insoles before, but never to that extent.
I think that is the way that industry's kind of going. Companies like Zellerfeld, they're partnering with Nike, and I think they're releasing a whole 3D printed shoe, the Air Max 1000.
Oh,
it's all
Nike?
printed.
You say Nike?
Yeah, Nike.
Okay, I don't know, that was like a UK thing. I'm like, Nike. I think he means Nike.
Yeah,
That's quite common. Nike and Nike are interchangeable.
Yeah, I think they're going into production with it, with the Air Max 1000 as a whole printed shoe onto the commercial lines. Oh, I don't know if it's actually going ahead, but they've hinted that it's going ahead.
We've seen the Adidas 4D, right, with the 3D printed midsole that's done on Carbon 3D printers. Carbon, the company, not carbon fiber. I think they're cool, but I'm told they're very heavy. I don't own a pair. I was supposed to buy them and I forgot. And by the time I remembered to buy them, it was too late. Nonetheless,
Yeah, I'm coming in the market looking for some shoes, and I really want them to be 3D printed.
the Adidas 4D is probably the best out there right now. Big Tree Tech or BQ, somebody reached out to us for 3D printed slides, and I'm like, oh, I live in Florida that gets muddy out here. That, you know, you could see all like it was resin printed, so you had all this like interior geometry stuff. I'm like, no, the first time you step in mud, you're never able to clean that. It's dirty forever. It's dirty forever.
Yeah, they're doing more kind of like FDM stuff. The process is basically FDM. What companies like Zellerfeld.
Yes, from my understanding, that's what they're doing.
Yeah, I just don't know how good the durability is, how long they'll last, and that kind of stuff.
Well, they are made of like TPU, and TPU is like a really durable material naturally.
Yeah, but then you want your shoe to last maybe 2 years or a year or something.
Yeah, like at those prices, you want them to last ages. Like I have actually, do I have my shoes here? Oh, I don't. So I have some, oh God, do you remember what they are, Grant? Because you're the one that knows the brand. I don't. You're the one that told me about it.
Oh, Brooks?
No, it started with an A. It was like Adidas or whatever.
Adidas?
No, it's not.
Asics?
A6. That's it. So I had some A6 trainers, and they were really good because you could get them in non-uniform sizing. So I got a 10.5 for my left and an 11 for my right. Brilliant. I love that I could get them in alternative sizes, and they've lasted me a good 6-7 years. Like I had them before I went to university, and that was almost a decade ago now.
But yes, I was going to say that Hugo Boss just started selling a shoe where you scan your foot and they print it. There was
with like an iPhone or something like that.
Not sure how they're doing the scanning. Might even be in store. But it was released last week. A shoe that you scan your foot and then they print the custom loafer for you. I'm surprised it's Hugo Boss. You'd think it was a sportswear company that goes for it first.
I mean, at the moment, literally every single one of my shoes has a printed insole just to like properly form to the bottom of my foot. Having a printed shoe is something that I'm really interested in getting. Also, I just like the fact that if I'm out and about, I've always got something 3D printed on my body that I can go like, printed.
How do you do
Like
insole? Do you design that?
50-50. So I started initially, so I went to a podiatrist. They gave me a orthopedic insole, which are frankly crap. They are useless. The problem is they give you this full insole. It's hard plastic.
Yes.
It's just rigid plastic.
Yes.
So that you put it in your shoe and then you have to walk and your foot is supposed to bend. It don't bend. So you walk like a duck with your feet being completely flat.
And that's why you have to scan your feet both in the air when there's no pressure on them, and then normally you just do an impression into floral foam, and then you scan the floral foam with how you're weighted. And that's the way that you do it right. So you can look at how you're your foot naturally sits and then the way when it's weighted, how it sits.
No, I didn't do that. So what I did was I did the photogrammetry route on the insole. So the hard, rigid orthopedic insole, I put masking tape over it. So it was a nice matte material. Got 3 different Sharpie colors. So it was red, green, and black. I drew a load of zigzags over the surface. So I had really nice tracking sharp edges. And then I just photogrammetried the entire part, took it into Blender, smoothed it out a bit, cut it down so it was only a half insole because I only really needed a half. I'm paranoid when it comes to like a little bit of like self-made medicine-esque health. So I didn't want to just put plastic on my feet. So instead I made a 2-part mold and I cast a medical grade platinum silicon because the platinum silicon is self-cleaning because I just didn't know like what bacteria like
it's easier
foam can
to
pick up
clean.
over time.
Says the
Yeah, I
guy that
never
says he
cleaned
wants
them.
more macroplastics
I
in his
never
body.
once cleaned them. They're platinum grade silicon. They're yellow. But I have them in all of my shoes now. And that was the best decision I ever made, where I could walk for 10 miles and my feet would never get like that weird middle hurt pain where you get a flat foot. Never got that with them. And I'm never going away from it because it is so nice to have a nice soft insole.
This is where 5-axis to me, because you guys can do the curvature on the surface. You can do the non-planar 3D printing and get that curvature for like as dumb as it is, the business model for me is like it's custom insoles. It's anytime I can do non-planar 3D printing, it's custom insoles, it's custom like cane handles. It's all about accessibility and how I see it.
Though I actually have a real world use case that blew somebody's mind. So before I started the company, I did a process called the Prince's Trust. In the UK, that is it's almost like an incubator for young adults. I was only like 16 at the time. Yeah, and they kind of like teach you about tax and they teach you about business practices and all of that jazz. The person who was heading it up, their entire business was these soft grip covers for medical grade canes, because obviously the ones you get at the moment, they're like that weird hard-ish grey plastic. Their entire multi-million-pound business was just soft, like neoprene style grips. And I literally just turned around to her going like, you can print that. You don't have to buy injection molds anymore. And it literally blew her mind. But now that if you could print directly on the handle, that would make it so much better, because the only issue she had was they'd spin in place. They weren't a strong enough grip to keep them soft as well as being formed for the handle. That'd be a great little solution.
It depends on the material. You can print it quite well and get good adhesion if it's material to material, same material. If you're looking at different materials, then it's harder to bond directly. But you could use like an industrial glue to then just really make sure it's bonded.
We all love our industrial glues.
I think it's cool. It's a great way, especially when we look at like getting young kids involved in the industry. That's the kind of thing that flips their mind just enough that they leave with more intrigue than when they started. And especially for the young gamers out there, that kind of thing is so important, is to keep them interested, because they'll fall out of this stuff pretty quickly, I think, otherwise.
Yeah, and they're the kind of skills that you need going forwards. Robotics for multi-axis printing. It's kind of a gateway into those bigger applications like large format robotic. And then generative design too. If you're an engineer, you kind of need to learn about these methods, topology optimization, designing structures, those kind of things. But I agree. I do,
especially as it gets more popular as time goes on. Like the computer's only getting better and more of manufacturing is going computer heavy.
Yeah, I got into printing. It was really because of the RepRap project. So what I think ultimately would be cool is to do something like that, but with multi-axis, 5-axis printing.
That would be cool. Just maybe not out of wood. We could use wood fill filament. I'm fine with that. Gents, is there anything that you want to leave the folks at home with regarding Generative Machine, the future machines, what you guys are currently doing, ways for people to check you out, that kind of stuff?
I would just say, we're getting ready to putting it all together to launch soon. So we'll try and keep people updated, share some images of our progress from time to time. We're on LinkedIn. That's usually where we share stuff, sadly. But that is where you can find things. And that's more or less it from me.
That is all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Downtown Abbey, I've heard of it, but I've never seen it. Really?
No.
I was so excited to talk about that. Now
I've actually never watched it, if I'm honest.
The funniest bit is I actually warned Grant before this entire show about British humor. And I told him they were literally putting a server rack in the trash. And I'm like, this is a brand new server rack going in the back of my car. Do not put a server rack in the back of the car, by the way. It does not fit. I look like an absolute twat with this massive double-length server rack coming out. You've not seen the guy. It was the 2002 Honda Civic Mac. It was a lovely car, which was not designed to have 380 kilos worth of granite in the boot at all. You put any pressure on the accelerator, the front wheel spin because there's just not enough grip.
You were squatting Hondas before it was cool. It was never cool. Don't ever squat your vehicles.
Do it. Grant can't tell you what to do.
No,
Live your life.
it's so bad they're illegal.
What is it?
No, it's
Squatting.
squatting your vehicle.
Take your car,
lift the
lower
front
it.
of it. No, but
Only
no,
lift
no.
the front.
You lift the front.
I've only ever heard of squatting as in all four at once.
No. Look up a squatted truck.
I'm going to piss so many people off.
I'm-
But this looks like ass.
And you're not gonna piss people off. It's terrible.
These are trucks where you already can't see people standing in front of them because they're so bloody tall.
Look, they don't have a lot of brain cells, the people that are squatting their trucks. The brain cells are minimal at best. And when you have two brain cells fighting for third place, maybe that is what happens. Rob Lutters, that's got to look towards God. Squatting the truck. What is your favorite food and why?
Is it Marmite?
I quite like pig's ear.
Is it actual pig's ear?
Yeah, it's a Portuguese dish.
I don't think I've ever had that before. Is it like...
It's different. It's not instantly nice, possibly.
I'm not
I'm
certain that you're
Portuguese,
winning
so-
me over on this when you say it's not nice initially, but it gets better. Like, you're not...
Yeah, but that's like my favorite drink. My favorite drink is the first time you taste, you go, ooh, and then you come back to it after 3 more and you're like, I can't live without this now. Just realized that wouldn't work in America because they don't have the same safety standards we do. You just end up killing yourself.
It's obviously wrapped in
toaster
a...
bath. Come on, man. What's the fun if the printer can't hurt you?